The video has started. I hope you didn't think that I made a mistake. Hi. Okay, this is your review video for Unit 2B. Okay. Here's a function. It's quadratic. Okay, so two things that we're gonna talk about today, two main themes, okay? First, I want to talk about the transformations. How did this quadratic get to where it is now? Now, the transformations that we're going to talk about with regards to what's on the test is not all of the transformations. That's an entirely different unit that's coming later on when we get back from winter break. Now, all quadratics, and I think I mentioned this a few times before, start here. Okay. Now, this is not a perfect representation, but the part that is perfect is that the origin or the vertex is at the origin, which is the vertex at the origin. So it's 0, 0. That's called the parent function. And that parent function is f of x equals x squared. Okay, so all quadratics start from that. Okay, it's kind of right in the middle of the sunlight there. Let's do this again. Okay, so f of x equals x squared. So origin as intercepts, the vertex is 0, 0, obviously, or f of 0 equals 0. And that's what it looks like. Now, how did this get to that? Well, we can just clearly kind of take a look and see. So remember, my scale here is by ones, right? So this goes to -5. So I need you to tell me what actually physically happened with regards to the directions. The origin is here or the vertex is here, right? Here's the vertex of the other function. 1, 2 means I went left 2. Okay, so you can write left 2 just for now. And then I went down 1, 2, 3, 4. Down 4. Those are the two transformations that occurred to this function. Now, how does that look when I change this? Okay, well, f of x equals the quantity, some quantity, and then you have a number here, you have an x here, and then I got a number in the back. Now, down and up is easy, because at the very end of the function, meaning all the way at the back, and again, I wrote in the sunlight, so hopefully you can see that. Down 4, down means minus, so this is -4, okay? Now, left 2, well, I gotta put a number in here. And putting a number in here, remember, is the liar. It is the opposite of what you really want to write. Well, left 2 means -2. But because it's a liar, I have to switch that sign. Now it's a +2. Here's the function. This function is now the function that you see on Desmos. And I can confirm the function, or the equation of the function, because of the vertex, or the minimum value. It's the opposite of this and exactly that. Well, the opposite of this and exactly that is -2, -4, and that is -2, -4. So when you're looking for a transformation, you're looking for where the function moved to. Now that I have my function, let's talk about the characteristics, okay? So if you want to pause me, okay, and you want to write down the characteristics yourself, I think that that's a good idea. What did I say this was? Okay, now, you need to know all the characteristics and you need to understand what the characteristics are. So let's do one thing at a time. So I'm going to write the characteristics down here. And then you're going to find them for me. Now, on the test, you're going to have a visual representation on almost every single question if I ask you a characteristic, except for maybe one multiple choice and the constructed responses. Okay, so you should be able to graph any kind of a line with an XY table or a T table. Okay, let's do AROC on 0 to 3. EB stands for end behavior. Let's do increase and decrease, positive, negative, and then min-max, which is the vertex, but we've already done it. So 1, 2, 3, 4, 5, 6, 7, 8. Let's stop there and let's do that, okay? So if you want to pause me, go ahead and try these out, and then I'll work this through together with you. You're back. Thought I got paused myself, but that didn't work. So you'll have both the function and you'll have the equation, so graphically and equation-like. So you can solve these. The domain should be relatively simple. You should have got -infinity to positive infinity. It's always -infinity to positive infinity, okay? -infinity, x values go forever to the left because the function does go to the left. All the way to the right, it does go to the right. So, the range, remember, lowest value to highest value. Well, the lowest value you already know because I know that my minimum is at -2, -4. So it actually touches -4, and it goes to positive infinity. That's the range of this function. The intercepts, well, I can see them, so it's pretty simple, okay? My x-intercepts are 0 and -4. My y-intercept is, again, 0. Okay, so it is as easy as that. Now, I've been forcing you guys to do this algebraically. You don't necessarily have to do that here because you're going to have a visual representation on a graph. So you're welcome, okay? Let's skip AROC for a second because that takes the longest to do. And behavior. Okay, you need to know the script, and the script is this. As x approaches negative infinity, f of x approaches what? Okay, so basically what that says is, as x goes left forever, where does y go? Well, in this function, it's clear. X going left, y goes up. So y going up means positive infinity. You can write the plus sign, or you can just write the infinity sign, but I don't know what the test is going to say. It might have a plus in front. That's okay. It's the same exact thing. And then the other one, so that's half of the equation, or half of the script. The other half is as x approaches positive infinity, f of x approaches what? And all quadratics are wonderful in this aspect. If it goes up on the left, it's got to go up on the right because it's got symmetry down the middle, which means it has to go to the same side on both ends of x. So it's both positive infinity on both ends. Increase, decrease. So I'm going to go ahead and erase this stuff. So we can talk about increase, decrease, positive, negative. Increase and decrease. Okay. Again, you're going to have a visual representation, so you're not going to have to figure out, oh, what did I have to find out first before I did that? This function is clearly decreasing. Where is it actually decreasing? It's decreasing where my finger is, and then it all the way up, so all the way down to here. But I want to represent increase, decrease by x values. So it's decreasing. It starts to decrease at negative infinity. Okay? And I say starts because there's no start or stop here, but we have to have a value that represents where it would begin. And it stops decreasing, 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 decreasing. Here is where it's not decreasing anymore. Well, it's not doing anything. But I want the x value of the decrease. And the x value of the decrease is negative 2. It's always parentheses with increase, decrease. Never, never, never different. It's always parentheses. So if you see a bracket on the test, cancel that problem out. Cancel that, that letter out. It's not going to work. Now the increase, it better be exactly the opposite of that. It begins its increase at negative 2. And it goes to positive infinity. All right? So that's your increase and decrease. Clear. It's decreasing here. Tell me what the x interval is. It's increasing here. Tell me what the x interval is. All right? Positive and negative. Kind of the same concept, but you're looking for where the function is above the x-axis for positive and below for negative. Okay? So let's do the negative first because that's almost always easier. Here is where the function is negative, meaning it's below the x-axis. I'll do that again. Here is where the function is negative. It's below the x-axis. So basically what I'm asking you to find is, what is the interval of x? Meaning, what is the section of x that it's below the x-axis? And this is the section that's below. I just need you to tell me what that interval is from the beginning to the end. So, these are always parentheses as well. Right? Never brackets. It starts being negative at negative 4, and it stops being negative at 0. Done. That's the negative part. Now, the positive part's a little bit more challenging because there's two sections, like two separate sections. Here is where it's above the x-axis, and here. Okay, so we have to represent that with a u, meaning union, meaning and. Okay, so it begins being positive. Again, it begins being positive at negative infinity. Because all the way to the negative infinity on the x-axis is going to be there. It stops being positive at negative 4. Oops. Union, that's supposed to be a parenthesis. And, right, because there's two different sections. It has a break in here. Like, this isn't consistent, right? Or continuous is what we say. 0 to positive infinity. Now, you can always check your work to make sure you're doing the right thing here, because the negative and positive, when you kind of put all that together, it better tell the story of the entirety of the x-axis. So, for example, negative infinity is where this thing begins. It goes to negative 4. Then it picks up at negative 4 on the negative side, meaning so I'm now accounting for every value, to 0. Then it picks up again 0, positive to infinity. What I'm trying to say with that is, positive and negative, when you line it all up, it better tell the entire story of every value that exists on the x-axis, which is negative infinity to positive infinity. So it's kind of one fluid sentence. We're at 9 minutes and 35 seconds. It's a long, long video. Min, max. Ooh, 0 to 3, sorry. Min, max, we already know it. It's the opposite of this and exactly that. It's negative 2, negative 4. Okay, and it's a min because there's no negative in front. All right. Last one, AROC. Okay, so You're going to need to be able to do this algebraically, because I think one of the questions on the test, or two of them on the test, is it just gives you the interval that I'm looking for, and then you're going to have to actually find it, because I don't think there's a graph. So these are both x values. So basically what I'm looking for is this. What is the y value when x is 0, and what is the y value when x is 3? So I'm just going to plug these values in. Well, I already know what it is when x is 0, because that's the y-intercept. So when x is 0, 0 plus 2 is 2, times squared is 4, minus 4 is 0. So the function's value when x is 0 is 0. Now the function's value when x is 3, let's plug it in. 3 plus 2 is 5, 5 squared is 25, and 25 minus 4 is 21. So now I'm going to plug in these numbers into the slope formula. Okay? So that's the average rate of change. 21 minus 0 over 3 minus 0, this is pretty simple. 21 over 3 is 7. Now, that is the average rate of change on the interval 0 to 3. So from 0 to 3. Here's a point on the graph. And if I were to go up, I can't see it because I can't scroll up. I'm looking for what that is. Now, that's relatively linear. But some average rate of changes, like I would ask you for, let's say, 5 to 0. And then you would have to find that slope. Okay, so that's what average rate of change is. All right? Not bad. So hopefully you did that. If you didn't understand it, go back again, try another one. And you can go to Desmos and plug in any function that you think of, and you can go through these characteristics as well. And let me know if you have any problems with that. You also need to know the difference between a relation and a function. This is clearly a function because it passes the vertical line test. Understand that, please, for me. A circle, for example, or a square, or anything that doubled on itself, like this is not a function because it fails the vertical line test, meaning that line that I just drew goes through that function twice. Let's see, what else? The real world scenario, it was number 8 on the Around the World yesterday. You need to be able to graph a line. Graph a function in context. Now, it might be linear or it might be quadratic. I don't know. But if I give you some information, like where the function begins, so really quickly, it's likely, because it's a real-world scenario, it's likely only to be in this quadrant, meaning when it's positive x, positive y. Real-world scenarios very rarely ever go over here to the left of the x-axis or below. Now, it would go below the x-axis or the y-axis. It would go below the x-axis if we're talking about something that's below sea level or losing money or something to that nature. But other than that, we talk about real-world scenarios in quadrant 1, where both values are positive. Let me know if you have any questions. Have a nice day. Bye. 12 minutes. Oh my God, so much long. Ah! That's weird. See that? That's weird. It's like an icon. All right, goodbye.